A is a vector function. A dot A is giving us a scalar function. So essentially, we know that solenoidality is not applicable to a scalar function. So it cannot be something said to be solenoidal. Do you understand what I'm talking about? A squared is now a scalar. A squared is A dot A, it is a scalar. You do not talk about the solenoidality of a scalar. You can only talk about the solenoidality of a vector field because solenoidality means that the vector field A is solenoidal, it means nabla dot A is 0. So it has to be a vector field that we're saying that it is solenoidal. This cannot be something solenoidal. This is a scalar field to start with, okay? And in the same vein, for the same explanation, this cannot be said to be irrotational. And at the same time, also normal means that it is mutually perpendicular, and that cannot even make sense in this context, okay? So that simple elimination would have actually given us this result. Can you see that without even going through this process? Can you see another confirmation that most times when something gets very complicated, it may mean that we are actually missing out some basic fact about it. Okay, so that is that about that. Life could be as easy as that. Okay, it just came to my, it just occurred to me now while I'm going through this whole thing again.